Hey class, this is lesson 7.4. In this lesson, we're going to learn how to raise the power to a power and to raise a product to a power. I'm going to suggest that you do this on your own first, so you can kind of get a feel for what the properties are that we're going to learn about. It helps you give an understanding, gives an understanding to why we're doing what we're doing. Go ahead and pause here and try these problems. You can check back up with the answers just to make sure you're doing it right. What you should have noticed here is when you take a power to a power, it makes sense that we multiply the exponents. So the exponents are multiplied. And so for this problem, you should be thinking, I need to do this. 11 times 33, and that's going to equal the 363rd power. Go ahead and pause again and try the second part here. All right, what you should have noticed here is that the exponent is distributed to all the parts inside the parentheses. So let's just say the exponent is distributed. And so if we want to simplify this, in other words, simplify means get rid of the parentheses, then we have to do r to the 20th times s to the 20th. All right. So go ahead and do this review. Check back with your answers. All right, so here's the property. This is raising a power to a power. So we're going to use this, and what you just noticed in that previous exercise is that when you raise a power to a power, in other words, when you have a power inside the parentheses and then power outside, you need to multiply those powers. And that's what this is saying right here, m times n. So, for instance, let's make a name for this too. Let's call it the power property. All right. So yeah, if we expand this expression, we're going to multiply 4 to the second by itself 3 times. That's what that 3 right there means. And when we do that, we really have to add 2 3 times, or do 3 times 2, which is 6. Here we're going to expand the expression and multiply w to the 5th by itself twice. That's what that 2 means. And that's going to give us w to the 10th. So the shortcut here is we know we need to multiply those when we're raising a power to a power. So we get 5 to the 8th. 3 times 5 is 15. So now as we do this problem 1 here, you can think of this 5 if you want, just to make sure you're doing it right. That means the base is b to the 3rd, and we're multiplying that by itself 5 times. That's what that 5 tells us. So you can expand it like this if you want, and then just add up how many times you're multiplying by the base b, which in this case is 15. Or you can just do, when you're taking a power to power, multiply the 2 powers together. So go ahead, you try that on problem 1 here. All right, what is the simplified form of h to the negative 2nd times h to the 4th to the negative 3rd? All right, first we want to write let's first write these, since we have the same base here, let's write this whole thing using a single base of h. So we want h to some power. And then if we have a negative exponent, then we'll deal with that. We don't, when we're simplified, we need to have just positive exponents. So we'll see what we have there. But notice we're taking a power to a power there. So we have h to the fourth to the negative third power right there. We can multiply, and that gives us h to the negative 12th. And now we have the same base. We can just add the exponents. That gives us h to the negative 14th. And then to get rid of that negative exponent, remember the negative exponent means you're dividing by that base h. And this is how I like to think about it. H to the 0, any number to the 0 power is 1. So if I start at 1, negative 14 means I'm going to be dividing by the base h 14 times. And I can represent like that. And then that would be considered simplified because it has a positive power there. All right, go ahead, you try it. See if you can get the right answers here. All right, this is our raising a product to a power. Actually, I'm going to call this property the distributive property of exponents, because when you have something in parentheses, an exponent outside the parentheses, everything inside the parentheses has to be raised to that power. So, and that's what this is saying. Notice we have both the 3 is raised to the 4th power and the x is raised to the 4th power. And then to simplify it, any real number you have there, you can get rid of that exponent, so 3 to the 4th power is 81. So let's see what happens here when we represent this area of this square. Remember that the area of a square is basically the area of a rectangle, base times height, length times width, however you want to look at it. So the area, and since a square has both dimensions the same, we can just say the area is s squared. So we take the side and we square it. So that's going to look like this. And now we have a power to power, and we also have two things inside the parentheses that need to have that power of 2 distributed. So we're going to do that. So we get 4 to the 2nd, and then we have x to the 5th that we need to raise to the 2nd power also. 4 to the 2nd is just 16. And when we raise a power to power, we multiply those. So 5 times 2 is 10. So we're going to choose C for that one. All right, go ahead, you try that. All right, that's what your answer should look like. All right, simplifying expression with product. So here we have a whole bunch of stuff, powers raised, all that. We're going to use the distributive property of exponents here, and we're going to use the power to power property. First of all, let's simplify this part right here. When you're multiplying, when you're taking a power to a power, you need to multiply the exponent, so that we're going to simplify that to b to the 18th right away. Now here we have a 8a and b to the negative 4th, all that need to be raised to the 2nd power. So let's do each one of those individually, distribute that power of 2, so we get 8 squared times a squared times b to the negative 4th squared. Then I'm going to simplify this b to the negative 4th squared. When you take a power to power, you multiply them, so that's b to the negative 8th. We have a to the 2nd, 8 to the 2nd, and b to the 18th. Now these two, if I use a commutative property, I can switch them around and I can multiply those two together. And so when you have the same base, just add the exponents, multiplying by b 18 times, and then subtracting 8 of those off, because that's dividing by the base b, gives you b to the 10th power. This 8 to the 2nd power, we can write that as 64 since it's a real number. And I'm just going to put it in alphabetical order. A to the 2nd, b to the 10th power. All right? All right, you should get something like that. Raising a number in scientific notation to a power. The formula for volume of the sphere is volume equals 4/3 pi r cubed, where r is the radius. What is the volume of the sphere with a radius of 10 to the second power? Millimeters. Give your answer in terms of pi. So here's our volume formula. And we are going to substitute 10 to the second for the variable r. So that's going to give us 4/3 pi times 10 to the second to the third. And if we simplify that power there, 10 to the second to the third, that's going to be 10 to the sixth power. And now we can just do a little math here. Depends on how we want to leave our answer. If we want to leave it as a power, usually though when we have a real number, we write that as the number. 10 to the sixth power is 1 million. 1 million times 4 is 4 million. And divided by 3, and then it said leave your answer in terms of pi, so we'll just do 4 million over 3 times pi. Okay. Could you try that? Substitute in these values for the variables and see if you can't simplify that. All right, lesson check. Error analysis, one student simplified x to the fifth plus x to the fifth is x to the 10th. The second student simplified x to the fifth plus x to the fifth as 2x to the fifth. Which student is correct? Explain. Well, when we do x to the fourth times x to the fourth, when we have the base the same, what we're wanting to know is how many total times are we multiplying by the base x. So that means we need to add the exponents. When we do a power to a power, that means the base is x to the fourth now, and we're going to multiply that by itself 4 times. So we're going to have 4 times 4 times the base of x. And then the last one, these terms are just being added together, so it's like adding a plus a, which of course wouldn't be a squared, so we wouldn't multiply them. We just need to combine like terms there, and we get 2x to the fourth, so the second student is correct. All right, that's the lesson. I'll see you tomorrow.